Welcome to my channel. In this video, we are required to find the values of x and y. X and y are members of the set of integers and x is greater than 0. Solution. Before I proceed, I will appreciate it if you like this video, subscribe to my channel if you haven't done so, and also share this video, because sharing is an act of love and love doesn't cost a thing. Well, that is debatable, but before I deviate, let's go straight into the question. I'm going to start with the very first equation, which is log to base 3 of x minus y plus log to base 3 of x plus y is equal to, now this one can be written as log to base 3 of 3. Now I will apply product law of logarithm here. Log to base 3 of x minus y, x plus y is equal to log to base 3 of 3. This will cancel this. Now I have x minus y, x plus y equals to 3. I can rewrite this as x squared minus y squared equals to 3. This can be the equation 1, or this can be called the equation 1. Now, looking at the second one, that is where we'll have to spend most of our time trying to simplify. Now, let me also state that this video is going to be a bit lengthy, but I'll appreciate it if you stay till the end of the video. Now, 4 to power x over y plus y over x is equal to 32. Let's rewrite this as 2 to power 2x over y plus y over x is 2 to power 5. These two will cancel these two because the bases are the same. We'll now take the powers. The powers are now x over y plus y over x equals to 5 over 2 if I divide both sides by 2. Now if I find the LCM of the denominator of the left hand side, I'll have xy. Now simplifying, this is x squared plus y squared equals to 5 over 2. So I will now have to multiply both sides by xy. If I multiply both sides by xy, I have x squared plus y squared equals to 5xy over 2. The reason I did not cross multiply is because I want to factorize this side. Now this side can be rewritten as 2xy plus xy over 2. Now I will take this 2xy to this side of the equation, giving me x squared minus 2xy plus y squared is equal to xy over 2. If I factorize this, I'll have x minus y all squared equals to xy over 2. Let's call this equation 2. This can also be the equation 2. We will have cause to refer to both equation 1, both versions of equation 1 and both versions of equation 2. Now to proceed, let us square both sides of equation 1. If we square both sides of equation 1, we have x minus y all squared, x plus y all squared equals to 9. We need to divide equation 2 by the this version of equation 1. So divide equation 2 by, let's call this equation x, by equation x. Equation 2 is x minus y all squared equals to xy over 2. I am dividing it now by this version of equation 1, which is equation x. That is x minus y all squared, x plus y all squared. This will now divide by 9. This will cancel this, remaining 1 over x plus y all squared equals to xy over 18, because this is xy over 2 times 1 over 9, which is xy over 18. So this is what I applied, or I did here. Now let's call this equation 4. I can rewrite equation 4 or equation 3. Let's call it equation 3 I can rewrite equation 3 as x plus y all squared equals to 18 over xy. That is our equation 3 properly. Now, to proceed, we need to subtract 3 from 2. This is equation 3 and this is equation 2. We need to subtract them. But before we do that, let's expand the bracket and also this bracket. Already this bracket has been expanded to this, and this one will expand into x squared plus 2xy plus y squared. We will have 18 over xy. That is our equation 3. Now our equation 2 is x squared minus 2xy plus y squared equals to xy over 2. We are subtracting this from this, or this from this rather. So this and this will cancel out, remaining this and this. So this times this is plus. I have 4xy because 2xy plus 2xy will give us 4xy. This and this will cancel out. We now have 18 over xy minus xy over 2. The LCM is 2xy. This divided by this is xy times this will have xy all squared minus this divided by this is 2. 2 times this is 36. We now have 4xy. If we cross multiply it, 8xy all squared equals to 36 minus xy all squared becomes the result. Let's now collect like terms. 9xy all squared equals to 36. Dividing both sides by 9, we have xy all squared equals to 4 and xy equals to plus or minus 2. Let us remember that x is greater than 0 and then that x and y are members, x and y are members of the whole number. But if xy is minus 2, we will not have obeyed this. This xy minus 2 is outside this set. Another reason is this: if xy equals to minus 2, now this part where we have x minus y all squared equals to xy over 2 will give us a complex number if we have to find the value of x minus y, because put minus 2 here over 2, we get minus 1, and then x minus y will give us the square root of minus 1, which is a complex number, and we don't want a complex number as the conditions in the question puts it. So xy is equal to 2. Having done that, we now need to solve equation 1, which is x squared minus y squared equals to 3, and equation 2, which is x squared plus y squared equals to 5xy over 2. We need to solve them simultaneously. Remembering that xy is 2, we'll put 2 here. So we have 5 over 2 times 2. This will divide this. So our equation 2 is x squared plus y squared equals to 5. We are solving 1 and 2 simultaneously. Let us add 1 and 2. If we add 1 and 2, this will cancel out, remaining 2x squared is equal to 3 plus 5. 3 plus 5 is 8. Let me write 8 instead of 3 plus 5. So x squared equals to 4. And if x squared equals to 4, x equals to plus or minus 2. Now, when x is 2, let us remember that x is a positive integer. So minus 2 is not required. So when x is 2, what is y? We will take 1 or 2 to find the value of y. Or we can take this expression where we say x times y is equal to 2. So when x is equal to 2, y will now be 2 over 2. Then y will now be 1. Now, this becomes the solution to the equation. Let us remember that we are asked to find x comma y. So x comma y is 2 comma 1. And 2 comma 1 satisfy the equation. If we put in the value of 2 and y, 2 and 1 respectively for x and y, we will have a balanced equation.